Uranus, the wayward wanderer of the solar system. Way back in 1781, William Herschel was looking through his telescope. He wasn't expecting to find anything huge, maybe a new comet or a faint star. But then, he spotted something different. It moved against the background of stars. It wasn't a comet, it was a planet. This was Uranus, the first planet discovered since ancient times. People were thrilled. Our solar system suddenly got bigger. This new world was way out there, far beyond Saturn. It was a faint, bluish-green dot in the vast darkness of space. Astronomers immediately started tracking Uranus. They wanted to map its orbit. They used the brilliant laws of gravity laid down by Sir Isaac Newton. Newton's laws were like the cosmic rulebook. They explained why apples fall from trees. They also explained why the moon orbits Earth, and they perfectly described the paths of Mercury, Venus, Mars, Jupiter, and Saturn. So, naturally everyone expected Uranus to follow these rules too. But Uranus, it turned out, was a bit of a rebel. This celestial misbehavior sparked a major scientific headache. So, the stage was set for a grand cosmic detective story. And every good detective story needs brilliant detectives. In this case, they weren't wearing trench coats and fedoras. They were armed with pens, paper, and the power of mathematics. Two such mathematical sleuths emerged, working independently of each other. They were separated by the English Channel, but united by their fascination with Uranus's peculiar orbit. On one side in England was a young, quiet genius named John Couch Adams. On the other side in France was the confident and established mathematician Urbain Jean-Joseph Le Verrier. Both were about to embark on an incredible intellectual journey. Their shared hypothesis was audacious. They both believed that the gravitational pull of an eighth undiscovered planet was the culprit behind Uranus's orbital shenanigans. They weren't just guessing. They aimed to calculate the existence and location of this phantom world, a world no one had ever seen, a world whose presence was only hinted at by the missteps of its neighbor. This was a bold leap of faith in the power of Newton's laws and the predictive capability of mathematics. The task before them was monumental. They had to work backward, in a sense. Instead of predicting how a known planet's gravity would affect Uranus, they had to deduce the mass, orbit, and current position of an unknown planet from Uranus's tiny deviations. This involved incredibly complex calculations, all done by hand. It required immense patience, skill, and an unwavering belief that the universe operated on logical, predictable principles. They were truly pioneers, charting unknown territory with the stars as their guideposts and math as their compass. By 1845, Adams had an answer. John Couch Adams, fresh from his academic triumphs at Cambridge, poured his youthful energy into solving the Uranus puzzle. He was convinced that an unseen planet was the key. Between 1843 and 1845, he meticulously worked through the complex mathematics. He calculated the likely mass of this new celestial body. He also pinpointed its probable location in the vast, star-dusted sky. His predictions were remarkably detailed, a testament to his skill and dedication. He was essentially saying, look over there at this specific spot, and you'll find a new member of our solar system. Armed with his calculations, Adams tried to get English astronomers to search for his predicted planet. He approached James Challis, the director of the Cambridge Observatory. He also sent his results to Sir George Airy, the Astronomer Royal at Greenwich. Unfortunately, things didn't move quickly. Perhaps they were skeptical of such a bold prediction from a young mathematician. Challis did conduct a search, but it was rather half-hearted and not systematic enough. Meanwhile, across the water in Paris, Urbain Le Verrier was also deeply immersed in the same problem. He was unaware of the full extent of Adams's work, just as Adams was largely unaware of his. Le Verrier published his initial results in 1845 and followed up with more detailed predictions in 1846. His calculations, arrived at independently, pointed to almost the exact same region of the sky as Adams's. This remarkable convergence was a powerful sign. It suggested that their mathematical reasoning was sound. Two brilliant minds using the same laws of physics had essentially triangulated the position of an invisible world. Le Verrier was absolutely certain his calculations were correct. Le Verrier, frustrated by the lack of immediate action from French observatories, cast his net wider. He knew his calculations were solid. He just needed someone to look. So, he wrote a letter. This letter, dated September 18, 1846, was addressed to Johann Gottfried Galle, an astronomer at the Berlin Observatory in Germany. Gala was known for his skill and had access to a good telescope. Leverrier's letter contained his latest, most precise prediction for the unknown planet's location. It arrived in Berlin on September 23rd. Gale, intrigued and perhaps a little excited by the confident Frenchman's request, decided to act on it immediately. Fortunately for Gale and for the history of science, he had a keen young assistant named Heinrich Louis de Rest. De Rest was a student at the time, but he made a crucial suggestion. He proposed they compare the view through the telescope with a newly published, very detailed star chart of that particular region of the sky. The Hora 21 chart of the Berlin Academy's Star Atlas. This chart was so new it wasn't widely available yet. If they saw a star that wasn't on the chart, and it showed a planetary disk, rather than a point of light, that could be their quarry. That very same evening, September 23, 1846, Johann Galle aimed the observatory's 9-inch Fraunhofer refractor telescope towards the constellation Aquarius. He pointed it to the coordinates provided by Leverrier. De Rest stood beside him, holding the precious star chart. Galle would call out the positions and appearances of stars he observed through the eyepiece. De Rest would then meticulously check them against the chart. One by one, the stars Galle described were found on the map. Then it happened. Galle described an 8th magnitude star. De Rest exclaimed, "That star is not on the map!" The news of the discovery spread like wildfire through the scientific world and beyond. A new planet, discovered not by chance but by the sheer power of mathematics and human intellect. It was a profound moment. But amidst the celebrations and accolades, a new, more earthly drama began to unfold. What to call this newcomer to our solar system family? Naming celestial bodies might seem straightforward, but it often involves tradition, national pride, and sometimes, a good old-fashioned argument. This new planet was no exception. The debate over its name became quite heated, particularly between the French and the British. Urbain Le Verrier, quite understandably, was the man of the hour in France. He had confidently predicted the planet's location, and it was found exactly where he said. Initially, he himself proposed the name Neptune. This was a fitting choice. Neptune, in Roman mythology, was the god of the sea. The previous planet, Uranus, was named for the Greek god of the sky. Following this classical tradition seemed logical. The bluish-green hue of the planet, reminiscent of ocean waters, also made Neptune an apt moniker. Many astronomers across Europe were inclined to agree with this sensible suggestion. However, François Arago, the influential director of the Paris Observatory, and Leverrier's staunch supporter, had a different idea. He publicly advocated for the planet to be named Leverrier. His reasoning was that planets had been named after their discoverers before. For example, Uranus was initially called Georgium Sidus, George's star, by Herschel in honor of King George III. Arago argued that Leverrier deserved this ultimate recognition for his brilliant theoretical work. French newspapers and much of the French public enthusiastically supported naming the planet after their national hero. For a while, French almanacs even listed the planet as Leverrier. The discovery of Neptune in 1846 was more than just adding another planet to the solar system. It was a monumental triumph for science, affirming the power of human reason. It showed that Isaac Newton's law of universal gravitation wasn't just a theory for nearby objects like apples and the moon. It governed the entire solar system, reaching its most distant corners. The universe operated according to predictable, mathematical laws. This gave scientists immense confidence that we could understand the cosmos. Neptune's discovery was a testament to the predictive power of mathematics. Astronomers didn't stumble upon Neptune by accident. Its existence and location were predicted through calculations, using the gravitational whispers it imparted to Uranus. Leverrier and Adams, with pen and paper, discovered a planet before anyone had seen it through a telescope. This was a new paradigm in scientific discovery, the mind grasping the unseen, guided by mathematics. It was a profound intellectual achievement. This discovery by calculation impacted how astronomers and physicists approached their work. It showed the universe as a system whose workings could be deciphered and hidden components inferred. It inspired future scientists to trust their theories and models, even when pointing beyond current observational capabilities. The search for other celestial bodies, the understanding of galactic dynamics, even the hunt for dark matter today, owe a debt to the methods pioneered in the quest for Neptune. Neptune's discovery is a story of cosmic detective work, intellectual perseverance, and international collaboration. It reminds us that the universe is full of wonders, waiting for curious minds to uncover them. Mathematics is a powerful tool for exploring and understanding reality. Every new discovery builds on the legacy of those 19th century pioneers who predicted a planet with the point of a pen. The quest for knowledge continues, and the cosmos still has plenty of secrets to share.